All right, let's get right into it. We are about to break down one of the most critical, most high-stakes balancing acts happening inside your body literally every single second. I mean, it might sound dramatic, but in a very real way, it does. Think about it like this. Your body's entire chemistry is like a perfectly balanced seesaw. If it tilts just a little too far one way or the other, well, things start to go wrong fast. And believe me, this isn't just a cool metaphor, it's a hard physiological fact. So what's the magic number we're aiming for? It's this, 7.40. That's the sweet spot, the perfect center point for your blood's pH. But the number itself isn't the whole story. The real drama is in just how narrow the range is. Get this, the entire range that your body can tolerate, the range that keeps you alive, is just 1/10 of a point. We're talking 7.35 to 7.45. That's it. If you dip below that, you're in a state called acidosis. If you creep above it, that's alkalosis, and neither is good. So the big question is, who or what is keeping this incredibly delicate seesaw perfectly level? Well, it's not just one thing. It takes a team, and the star players on this team are your lungs and your kidneys. But here's the cool part. They have totally different ways of getting the job done. Think of your lungs as the fast responders, the first aid crew. They can literally adjust your pH in minutes just by changing how fast or slow you breathe. You see, they're in charge of carbon dioxide, CO2, which is an acid. The more you have, the more acidic your blood. Then you've got your kidneys. They're the methodical managers, the long-term planners. They work much more slowly, taking hours or even days to fine-tune things by controlling a base called bicarbonate, or HCO3. So what you have is this incredible partnership. You've got speed from the lungs and slow, steady precision from the kidneys. But, sometimes this system gets overwhelmed. So what happens then? Well, there are basically four main ways this seesaw can get dangerously tilted. It can either be a problem with the lungs, that's a respiratory issue, or a problem with the body's general chemistry, a metabolic issue. Let's break down all four. First on the list is respiratory acidosis. Just like the name says, it's a respiratory problem, and it's making the body too acidic. The seesaw is getting way down on the acid side. Your pH drops, and why? Because the PCO2, that carbon dioxide level, is way too high. Simply put, your lungs just aren't breathing it out fast enough. This all comes down to something called hypoventilation, which is just a fancy word for breathing too slowly. What could cause that? Well, it could be something that's depressing the brain's breathing center, like a morphine overdose. Or it could be a chronic lung condition like COPD, where the lungs physically can't get that CO2 out effectively, no matter how hard they try. Okay, now for the complete opposite scenario, respiratory alkalosis. This time, the seesaw is tilting way over to the alkaline, or base side. Your pH goes up because your PCO2 level has dropped. The problem now? Your body is getting rid of too much acid. And you've probably guessed it. This is the classic result of hyperventilation, or breathing way too fast. In a clinical setting, this isn't usually just from panic. It can be triggered by really serious stuff, like dangerously low oxygen levels, that's hypoxia, or even a life-threatening blood clot in the lungs, a pulmonary embolism. Fun fact, this rapid breathing can actually mess with the calcium in your blood, which is why people who are hyperventilating sometimes get muscle cramps. All right, so we've covered the lungs. Let's switch gears and talk about the other side of the team, the kidneys and the body's overall metabolism. First up here is metabolic alkalosis. Just like before, alkalosis means the pH is too high, but this time it has nothing to do with breathing. The problem is that the body has either piled on too much base, that's our friend bicarbonate, or it has lost way too much acid. So what kind of things cause this? Well, it can happen from something like severe vomiting, where you're literally throwing up all your stomach acid. It can also be caused by certain hormonal issues. And a really common one, especially in hospitals, is the overuse of certain diuretics, water pills, which can trick the kidneys into flushing out too much acid. And that brings us to our fourth and final imbalance, metabolic acidosis. Now, the pH is low again, but for metabolic reasons. This happens when the body either loses its bicarb base or, and this is the tricky part, it starts to build up some other kind of acid. Honestly, this one is often the most complex puzzle for doctors to solve, and it's serious. If the pH drops below 7.2, we're talking about a true medical emergency that might even need dialysis. So when a patient shows up with metabolic acidosis, doctors basically have to put on their detective hats, and every good detective needs their tools. The first and most important tool in this investigation is something called the anion gap. The anion gap is a really clever calculation they do using the electrolyte levels from a standard blood test. See, your blood is supposed to be electrically neutral. So by adding up the major positive charges and subtracting the major negative charges, doctors can see if there's a gap left over. And what is that gap? It's the smoking gun. It represents unmeasured negative ions, which in this case means a hidden acid is lurking in the system. And this simple calculation gives doctors two very different paths to follow. If the anion gap is normal, it usually means the problem isn't a new acid, but a loss of the body's base, bicarbonate. Think severe diarrhea, for example. But if that anion gap is high, that's the big clue. It tells them a new mystery acid has been added to the body. And now, the real hunt begins to figure out exactly what it is. And how do they hunt for these culprits? They use a famous and slightly gross mnemonic, mud piles. It's a classic in medicine. Each letter stands for a potential cause, a hidden acid that could be the villain of the story. We're talking everything from methanol, like antifreeze poisoning, to uremia from kidney failure, all the way to lactate, which builds up during severe infections like sepsis. It's an incredible diagnostic checklist to run through. But wait, here's where it gets really amazing. Your body is a fighter. It doesn't just sit there and let the seesaw tilt without putting up a fight. It has this incredible built-in buddy system called compensation. The logic behind it is so simple, but so elegant. If the lungs are causing the problem, the kidneys step up to help out. And if the metabolic system is the one messing things up, the lungs jump in to save the day. It's all about teamwork. They work together to try and nudge that pH to push that seesaw back towards the middle. And this is exactly how that buddy system works in the real world. So, for example, if you're in respiratory acidosis because your lungs can't get rid of enough CO2, your kidneys will start holding on to extra bicarbonate, that base, to try and balance things out. On the flip side, if you're in metabolic acidosis, your lungs will kick into high gear and you'll start breathing faster to blow off more CO2. It's this beautiful cooperative dance happening inside you all the time. This explains why the lab results for someone with a chronic condition like COPD can look so strange at first glance. You'll see their CO2 is really high, which is acidic because their lungs are struggling. But then you'll also see their bicarbonate is really high, which is basic. Why? Because their amazing kidneys have been working overtime for years to counteract the problem. That is long-term compensation in action, right there. So at the end of the day, why does any of this matter? It matters because understanding this delicate balance is absolutely crucial in medicine. Being able to read these values, to interpret this seesaw, is how doctors diagnose and treat life-threatening emergencies. Everything from poisonings and diabetic crises to patients in septic shock. It really is just a constant, silent, and unbelievably precise dance happening inside of us 24/7. And it really makes you stop and wonder, doesn't it? What other invisible miracles are happening inside your body right this second just to keep that seesaw perfectly and wonderfully balanced?